So in this video, we're going to learn how to graph any wave. So you'll learn how to graph any wave you could want. And this is what we're going to do. We're going to graph a wave of the form y equals a sine of bx plus c. So y equals a sine of bx plus c. So for example, y equals 2 sine of 2x. In this case, a equals 2, b equals 2, and c equals 0, because we're not adding any plus c. And then another example would be y equals sine of 3x plus 3. So in this case, a equals 1, b equals 3, and c equals 3. So those are a couple examples. And a, b, and c are just numbers. So I've drawn a picture to explain how to graph any wave. So first let's start with what c and b are. So minus c over b. So minus c divided by b. This number tells you the distance from the origin. So if minus c over b is positive, your c over b units to the right of the origin. And if minus c over b is negative, your c over b units to the left of the origin. So minus c over b tells you where the wave starts. So minus c over b is where the wave is actually not where the wave starts, it's where the wave equals 0, because the wave can actually go negative. So minus c over b, basically just think of it as telling you where the wave starts. But if minus c over b is positive, the wave starts to the right of the origin, over here. And if minus c over b is negative, the wave starts to the left of the origin. So minus c over b tells you where the wave starts, and I've drawn it right here to show you. So that's that. And next let's also talk about the b. So 2 pi divided by b, that tells you when the wave repeats itself. So I've drawn it here on the diagram. 2 pi over b, that's when a new wave will start. So after 2 pi over b units from where the wave starts, another cycle of the wave will start. So the wave starts at minus c over b units from the origin, and then it repeats itself after 2 pi over b units. And that's because the sine function is a period of 2 pi, but since we want to make a wave that doesn't have period 2 pi, we have to divide that by b, so that we get a period of 2 pi divided by b. So that's the reason why it repeats itself after 2 pi over b units. And then after another 2 pi over b units, it will repeat itself again. And now let's talk about what a is. A is called the amplitude. So amplitude tells how high the wave is. So I've drawn it on the diagram here. So the amplitude tells you how high the wave goes up above the x-axis and how high the wave goes under the x-axis. So this distance is a and this distance is a. So minus c over b tells you where the wave starts. 2 pi over b tells you when the wave repeats itself. And a tells you how high the wave is. So now that we know this, let's do some examples. I'm going to erase this now, so if you're taking notes, you should probably write that down. And so let's do an example. Let me just clear this. So let me draw my x and y axis. So let's just stick for positive waves now. So I'm going to do examples that are positive. So for example, y equals, let's do 2 sine of 2 pi times x minus 2 pi. So in this case, a equals 2, b equals 2 pi, and c equals minus 2 pi. So let's begin by drawing where the wave starts. So the wave starts at minus c over b units from the origin. So minus c over b is minus 2 pi, because remember c is minus 2 pi. So minus 2 pi divided by b, which is 2 pi. Now that's just positive 2 pi divided by 2 pi, which is just 1. So this wave starts 1 units away from the origin, so let's draw that. So if it starts 1 units away from the origin, then this point must be 1, 0. So the wave starts at 1, 0, 1 unit away from the origin, minus c over b, minus 2 pi over 2 pi is 1. So it starts 1 units from the origin. Now let's do when it repeats itself. So b equals 2 pi, so remember the wave repeats itself 2 pi over b after 2 pi over b units. So 2 pi over b. Well, in this case, b is 2 pi. So 2 pi over 2 pi is 1, so the wave will repeat itself after 1 unit. So that means the wave will start again at 2, 0. Actually, let's make that a little farther. 2, 0. That's when the wave will start again. And then in the middle is when the wave goes up, and then the wave goes something like this, right? So right in the middle is when the wave will start going down again. So the wave will start going down at 1.5, 0. So that's when the wave will start going down. And then in the middle of that is when the wave will reach the highest point. So actually, let's rewrite this as 3 halves, 0, because I don't like decimals. And then in between that's when the wave will, so the wave will go like this. And at the halfway point between those two, that's when the wave will reach its highest and lowest points. So that's where A comes in. So in this case, A equals 2. So the highest point the wave will reach is 2. Is 2 units above and 2 units below. So that means this point must be, let's say this is 2, this is minus 2. So this point must be, what's between 1 and 3 halves? Well, that's just 1 1/4, or 5/4. So this point is 5/4, 2. And this point down here, where the wave reaches its lowest point, is between 3 halves and 2 is 1 3/4, which is just 7/4. So this point is 7/4, -2. That's that point. Because remember, the wave reaches its lowest point halfway between when it starts going down and when it starts going up. So now let's just connect the dots. And that's the first part of our wave. And then of course the wave will keep repeating itself every 1 unit, because in this case 2 pi over b is 1. So the wave will repeat itself every 1 unit. So this is just an example of graphing a wave, and you can go back in the video to see the formulas for how to find the period and amplitude of the wave. And that's it for this video. Hope you like this video.